All right, so we have been talking about soil. We've made mention of the four types of soil. We've looked at we've looked at what each soil type is. We also looked at soil structure. I think we defined it, and we moved on to soil structure. We mentioned some physical properties of the soil that directly influences the the soil, the root growth, the drainage ability of the soil, the activities of microorganisms. We made mention of the fact that the soil structure is directly responsible for all these things that I've mentioned, and as such, a poor soil structure would have a negative effect on the growth of roots, the movement of water, the absorption of nutrients, and everything. We made mention of that. All right, so moving on, today we would look at the very unique properties of each types of each type of soil. Okay, so we'll take sandy, we'll take loamy, we'll go further into what makes them different from the other soil types. Okay. So as you have been told, this is a pre-recorded session. Okay, so it is not live. If you have any question, you have to write it down after watching the video. Next week, then you ask me before we start the lesson for next week. And please, there's an assignment at the end of the video. If you don't listen to the video, if you don't watch the video to the end, you can't do the assignment. Okay, so those of you that will be forwarding, please, I entreat you to just make time and watch the video to the end so you can do the assignment and send it to me. Okay, so let's quickly start. So like I said, we are talking about the very unique soil properties. We'll start with sandy soil. So if you remember last week, I said that I gave an estimate of the percentage of sand particles we have in sandy soil. Okay, I said that it is about 60%. For the sake of those that didn't write it or didn't hear, we've already defined what sandy soil is, so I won't define it again. I'll just go straight to tell you that the sand particles in sandy soil is about 60%, full stop. All right, now apart from the sand being the major particle in sandy soil, let's talk about the size. Now, the sand particles in sandy soil ranges from 0.2 millimeters to 2.0 millimeters. Okay, so we can further add to our notes that the size of the sand particles ranges from 2.0, no, 0.2 mm to 2.0 millimeters. Now, this is very small. Okay, this particle size is very small. Okay, so it is this property of sandy soil that gives it a, a fairly that gives it a good aeration. Okay, when we say aeration, the soil air, I'm referring to the soil air. Okay, so the smallness of the particle size makes it easy for air to pass through sandy soils. Okay, so apart from the aeration too, we can talk about the drainage. Okay, so sandy soils have good drainage. Please, when we say good drainage, it actually means that it has a poor water holding ability. Okay, usually when the good there confuses people. When we say something has good drainage, it means that it does not go the water easily flows through. Okay, so water easily flows through, so it does not hold water like the way clay can hold water for a very long time. So we can write that this makes sandy soils to be fairly aerated with good drainage. Uh, and by good drainage, we mean poor water holding ability. So kindly take note of that and don't forget. So like I said last week, you can add compost manure to any of the soil types out there. Okay, if you want to do cultivation, if you want to grow crops. Okay, so you can add manure to sandy soils to grow vegetable crops. Okay, the addition of the manure would give the soil a good nutrient capacity. Okay, it will give the soil good nutrient ability to support plant growth. Okay, now again, we are saying that sandy soils have a large amount of sand as compared to the other particles. So we can say that due to the high proportion of sand in it, it is very light. Okay, so let's just write it. The high proportion of sand it is very it is very light. Okay, it's also warm, and again poor water holding ability. So it means that it is also most at times dry and can be easily acidic with low nutrient content. So, what happens when we add manure to our sandy soil? What goes on there? Now, when you add organic matter to sandy soil, okay, remember that we said early on that it is the soil structure that influences almost everything that is happening in the soil. Okay, so your plants being able to absorb nutrients from the soil, your roots being able to grow well, soil organisms being able to do whatever they are doing in the soil well, it all depends on the soil structure. Okay, so when you add organic matter to your soil, in this case sandy soil, it improves the soil structure. That is what it does. Okay, so once the soil structure has been improved, then your sandy soil will hold water or retain water, and it will also be able to hold the nutrient content firmly. Okay, it will hold it together, and then your plant or whatever you have planted would have good access to any of these things: nutrients, water, air, everything. Okay, so we can note here that when organic matter is added to, no, let me just continue, it improves the soil structure to be able to hold or retain water, as well as its nutrients content. Again, when you add organic matter to your sandy soil, you can increases soil compatibility. Okay, and it helps bind. You see, sandy soil is very loose. Okay, so if you add the clay, sorry, if you add the organic matter to it, you it helps the sandy soil to bind. Okay, it binds together, it holds the particles together like the way clay is. That binding nature of clay, upon the addition of of organic matter to sandy soil, you can give sandy soil that property. Okay, so it increases soil compatibility, and then it also helps bind the aggregates together. Let me see whether I can write it here, comma, also, so add it to your notes, also helps bind the aggregates. Aggregate is spelled Regates together. So if the soil has this property, it can easily prevent erosion. Okay, when the soil particles are held together, bind together, it is difficult for erosion to take place. So these are some of the things we have to note down about sandy soil. So sandy soils have a light texture with a loose structure. We have already established that. Okay, we also said it has good drainage, meaning that it has a poor water holding ability. Now, it is this property of sandy soils, okay, that um causes leaching. Okay. And someone will ask, what is leaching? Okay, leaching is the movement of water, soluble plant nutrients. And please write this, okay? Leaching is the movement of water, soluble plant nutrients deep into the soil, deep into the soil, beyond the reach of plant roots, beyond the reach of plant roots, due to rain or excess irrigation, due to rain or excess irrigation. Okay, so that is how we define leaching. Okay, so you see leaching usually in sandy soils. Okay, the movement of water or soluble plant nutrients deep into the soil beyond the reach of plant roots due to rain or excess irrigation. So when leaching occurs, basically the roots of the plant are not able to have access to the water that the plant will need, the nutrients that the plant will need, because the rain or the excess water washes it deep into the soil. Okay, so how can we check it? You can check it by adding organic matter. Okay, that is how you can check leaching, through the addition of compost or organic matter. Okay, and remember that I said earlier on that when you add the organic matter to the soil, okay, you increase the what? The amount of nutrients, okay? And then when you increase the amount of nutrients in the soil too, you bind the aggregates of the soil together, okay? Remember that what is causing leaching is the fact that the soil is loose, and as such, water drains easily, okay? So when you introduce the compost there, you lessen how loose the soil is, okay? And then you also add nutrients to the soil, okay? However, then again, someone can say that doesn't sandy soil having a loose structure have any positive effect? Well, it does, okay? Now, the loose arrangement of sandy soil. So this is the positive. This one I won't write it. It's not in the note. You have to listen and write. This is the positive effect of the structure sandy soil has, the loose arrangement. Okay. Now, what I think I've already even said this. Okay. So the loose arrangement allows easy penetration of the plant roots. Okay. And facilitates movement of soil organisms. Okay. So we are not saying that sandy soil having a loose structure is completely bad. No, it has its upside and its downside. Okay, the upside is that soil plant roots can grow easily and freely. The other is that the organisms in the soil can easily move. Okay, however, the negative part is leaching. So, like I've been saying all the time, we need to keep an open mind. Okay, all right. So that will be it for sandy soils. Okay, we've said that the particle size is 0.2 millimeters. It ranges from 0.2 millimeters to 2. We've said that fair aeration. It has fair aeration, good drainage, and we've also established the fact that we can add organic matter to improve the soil structure. And what the organic matter does is that it will allow the soil to be able to hold water, and also what, give the soil more nutrients. Okay, we've also said another name for sandy soil is light soil because of the high proportion of sand. Okay, so I can ask you some physical properties of sandy soil, and you should be able to tell me that it is usually dry due to the good drainage ability. Okay, these things, they are not in the note, but you should be able to pick them from what we have been saying. Okay, you can also say that it is easily acidic due to the low nutrient content. Okay, this is a new point, it's already in the note. So these are physical properties of sandy soil that we have not mentioned. Okay, it is light, it is warm, easily acidic because of the low nutrient content. Okay, it has a good drainage, and it has a loose structure. You should be able to mention at least 5 physical properties of sandy soil off head. All right. Next, let's talk about clay soil. So again, we already know what it is. We have established that it has a greater percentage of clay particles than than the other soil particles. Okay, we said that it can hold water and nutrients for plant use. Okay, so clay soils can hold and retain water and nutrients for plant use. Now, clay soil has a good water storage ability. Please, water storage and drainage are different things. If you confuse it, you get it wrong. Okay, storing water and draining it is different. Okay, so note that clay soils have good water storage. When you're talking about clay soils, use the word storage. Okay, or if you think you'll be confused, just use retention, a good water retention ability. Okay, so this is the major characteristic of clay soil. Okay, the good water storage ability, and it also has small particle sizes. Okay, and the particles are tightly packed together with very little airspace between them. Okay, now most of us have seen clay soils before. If you haven't seen it, I mean, even nowadays they sell artificial ones. Okay, now if you look at clay soil, you realize that it is heavy. If you are comparing any clay soil out there to the typical sandy soil, clay soil is heavy. Okay, so usually it is difficult to work with in the rainy season. When you have clay soil around you and you want to cultivate in the rainy season, it is so difficult. Okay, because in the rainy season it is mostly wet, and I mean, there's a lot of water on the surfaces of soil. Okay, so when you are working with clay soil in such seasons, automatically you have a waterlogged soil. Okay, a waterlogged soil, and a waterlogged soil can impede crop growth. Okay, and it can also cause the plant's roots to rot. Okay, so please note them down, these are not written. Okay, I'm saying that a waterlogged soil can impede impede means to slow something down. Okay, so it can impede is spelled IMPEDE. A waterlogged soil can impede crop growth and can even cause plant roots to rot. Okay, and usually waterlogged soils, once you enter dry season, it becomes so hard and dry, making it extra difficult to use. Okay, now, yes, uh someone will say that, I mean, it's a clay soil's ability to retain water is a good thing. Yes, it is a good thing, but it is also its greatest disadvantage. Okay, why? Because it has a high water retention. Okay, now, if you are using clay soil, the likelihood of clay soil to be easily flooded after rains is so high as compared to sandy soils. Okay, once it rains, oh, clay soil floods very easily. Okay, so the high water retention is the greatest disadvantage of clay soils, because one, it easily floods. Two, the roots of the plant can rot because the water does not move, it does not go anywhere, it is in the soil, and so the root will just be there and it will cause rot. And then the plant can also develop infections. Okay, infections, so you note them down. So these are the advantages, sorry, the disadvantages of having clay soil. Yes, clay soil is one of the best soils out there, but you can also add some organic matter to it, okay, to help your plants grow well. uh Now, what I want us to talk about more or note more here is what we call a liming agent. Okay, lime, lime is a liming agent. Okay, calcium is also a liming agent. Okay, so you can add a liming agent to clay soil, okay, to enable the particles bind together to form clumps, especially when they are dry. Okay, note the ending of what I said, especially when they are dry, because of their high water retention. Once uh, once we are in the dry season or anything, you realize that they are so dry, so hard, as compared to sandy soils. So when clay soils are dry, very dry, you can add what we call a liming agent. An example is calcium or lime to it, okay, to help the soil particles bind together. Okay, and last week we mentioned the crops that would do well in clay soil. Okay, clay particles have a very smooth texture. Okay, very smooth texture. And of course, as I've said early on, the particle sizes are very small in nature. So because of their smoothness and their small particle size, you can they can occupy a large quantity of it, can occupy a very small space. Okay, so let's just note this down and then we can move on. So moving on to loamy soils. Last week we said that loamy soils is a combination of sand, silt, and clay particles together with some humus. Okay. Now, it is also referred to as agricultural soil. Okay. And it has a very high calcium content. Okay. Now, it is the calcium content in loamy soil that causes it to form lumps easily when it is dry. Okay, when we say lamps, it clogs easily when it is dry. Now, because loamy soil contains some small amount of sand, some small amount of clay. Now you realize that sand has its own disadvantage, clay has its own disadvantage, but because of the proportions of sand and clay that is in loamy soil, you realize that their negative effect is cancelled out. Okay, it is cancelled out in loamy soil, making loamy soil the perfect soil for agriculture. Okay, now again, if you would remember last week, we said that you can combine, okay, you can combine the various soils. Okay, we even looked at some of the combinations. Now, if you take loamy soil, the three major combinations of loamy soil are sandy loam, clay loam, and silt loam. Okay, these are the major combinations of loamy soil. Now, why are we saying that they are the major? Now, if you combine any of the three above, sandy loam, clay loam, silt loam, the following qualities will show in your in your soil. Okay, so here you can continue that the above combination gives the following quantities. The above combinations give the following quantities, as you can see on the screen. So the first quality is good water holding ability. Okay, the combinations give the following qualities. One, good water holding ability. Good water holding ability. So you add this to your notes. It's not on the video or on the screen. So add this to your note. Realize that I've left a space. The above combinations gives the following qualities. One, good water holding ability. Two, sufficient aeration. Aeration is soil air. I've said it several times. Three, adequate nutrient retention. Four, it encourages the activities of soil organisms. So if you do these combinations, these are the qualities that you get for loamy soil. So the root of plants, okay, growing in loamy soil will have good enough water, enough space, enough air. Okay, so it makes the plants grow well. And again, because of these qualities of loamy soil, it is the best soil for gardening. Okay, so kindly note it down. Loamy soil is the best soil for gardening. Okay, and I think last week we mentioned some examples of plants that can be cultivated in loamy soil. Okay, I think I remember mentioning sugar cane, cotton. Okay, now what, apart from the sufficient aeration, the adequate nutrient retention, there are also other qualities that makes loamy soil the ideal type of soil. Okay, now someone will ask, how can I maintain my loamy soil to make sure that it remains the ideal soil for my cultivation? Okay, now you can keep loamy soil open, okay, so that air can enter, some small moisture can, okay, in fact the sand particles already even do that. Okay, the sand particles in the loamy soil, so remember we talked about the advantages of the sandy soil. Okay, so those qualities, you see them in loamy soil. Okay, so the sand particles will make sure that the soil has enough air, water, and then moisture and sunlight are all able to move perfectly in the soil. Okay, then the clay and maybe the silt content there too. Remember that we said that clay holds water. Okay, and if it holds water, it means that it has a poor drainage. Okay, so the clay there would make sure that there's always some amount of water in your soil. Okay, it would also reduce the rate at which evaporation, I mean, even with high temperatures, you realize that your soil will have some small amount of water. Okay, so loamy soil is, yes, the ideal soil for farming. Okay, it is the best for gardening. It is also known as agricultural too, and I've said that it has a very high calcium content. So talking about soil, we cannot talk about soil without talking about soil nutrients. Okay, now before I go and dive into soil nutrients, now not every soil is fertile. Okay, and like I said, you can add something to soil to make it fertile. Now, if you pick a typical fertile soil, or if you want to know whether this soil may be fertile without performing any experiment, what you can observe is that the surface, okay, the surface of the soil, the color, it ranges from a dark brown color or a dark brown color to black. Okay, that so you can tell if you see a soil and these are the colors, or this is the color at the surface of the soil. Without performing any experiments, we can conclude that that soil is a bit fertile. Okay, all right, so let's talk about soil nutrients. Now, different types of soil have different nutrient content. Okay, so we know the different types of soil. Each soil has its own nutrient content. Okay, now plants in general, they require two forms of nutrients. Okay, based on the quantity needed for their normal growth. Okay, it is not only one type of nutrient that a plant absorbs from the soil to grow. No, they require different amounts of nutrients based on the quantity to ensure their proper growth. Okay, all right. Now, on the screen, you can see that the two forms of nutrients that plants need are macronutrients and minor nutrients, or you can say micro. Okay, so these are macronutrients and micronutrients. Okay, we have macro, we have micro. The minor there on the screen is not wrong either. Okay, yes, so macronutrients, as the name suggests, macro. Okay, so macronutrients are needed by plants in high quantities for proper growth. Okay, plants need it in high quantities for proper growth. Okay, now this is not in the notes. What are some of the examples of macronutrients? The three major macronutrients are: one, nitrogen. So you can continue from these are on the screen. These are: one, nitrogen; nitrogen. 2. Phosphorus. Phosphorus. Phosphorus is spelled Phosphorus. Phosphorus. And then last one is potassium. K. Potassium. All right, so these are the 3 major macronutrients needed by plants to ensure proper growth: nitrogen, phosphorus, and potassium. Moving on, there are other nutrients there that are also considered macro, but however we name them as secondary macronutrients. Okay, so on the screen you can see that I have written additionally other nutrients like calcium, magnesium, sulfur are sometimes considered as secondary macronutrients because they are required in amounts higher than the micro. Okay, so let's keep an open mind, very open mind for this. Okay, so if you are being asked to name or give examples of macronutrients, please for example, if the question limits you to 3, I expect you to name the main ones, which is the nitrogen, the sulfur, and the phosphorus and the potassium. But however, if the question does not limit you to 3, then you can add the secondary macronutrients. Okay, so let's kindly note it down, and then we can move on to talk about micronutrients. Talking about micronutrients. So again, as the name suggests, micro. So they are needed in what? Smaller quantities. Or you can say minor nutrients, okay? They are needed in smaller quantities for proper growth of plants. Okay? Examples include molybdenum, copper. I didn't write copper in the notes, so please note it down. Copper is part. Iron is there, boron is there, zinc is there, manganese is there, nickel is also there. Okay, so these are all minor nutrients that are required by plants to ensure a healthy and proper growth. Okay, now usually you find minor nutrients on the surface of soil. Okay, they are not deep in the soil. Minor nutrients are found on the surface of soil. Okay, yes, there's a way we used to measure them. I think those of us that will be reading agric in the secondary school, I think you go further into it. Okay, now we've been talking about nutrients. Even you, the human being, if you have low nutrients, your growth, if the nutrients in your body are small, your growth will be affected. Okay, it's same goes for plants. Okay, so a soil which is low in nutrients will produce plants with small leaves and poor root system. Simple as that. And on the contrary to a soil that is rich in nutrients, be it micro or macro, it will cause the roots of plants to grow better, bigger, however adjective you want to use, whatever adjective you want to use. Now, how? There will be a lot of nutrient absorption of the roots. The roots will be absorbing more nutrients, okay, which will cause the entire plant to grow well, okay, and it will yield the desired produce, which is the fruit. So there are some plants, you know from literature, you know that when you plant them, you are supposed to have bigger leaves. Your root system is supposed to be on point, everything, but the plant is not showing those characteristics. It means that the soil is lacking some nutrients, and you have to correct that deficiency. So as we are saying that um, um, some nutrients are needed by plants in small quantities, other nutrients are needed by plants in larger quantities. The same goes with water. Okay, not every plant requires the same amount of water. No, plant A requires a different amount of water than plant B to grow. So the same applies when it comes to water requirement. Okay, so you can add to your notes that water requirement of plants are also not the same of all plants. The water requirement of all plants are not the same. So like I said, some plants will need more water than others. So please add this to your notes. The water requirements of all plants are not the same. Some plants will need water than others. Okay. And the soil in which the plant is into should be able to provide an adequate amount of water to the plant. Okay, so let's note these things down. And like I said, if you have a question, please don't hesitate to write it down. Then next week you can ask. Okay, so sandy soil, clay soil, loamy soil, they all have their nutrient content. Okay, experiments can be performed to know the nutrient content in soils. Okay, and I also mentioned some that you can, just by looking at the surface of the soil, you can tell whether this soil may be fertile or not. Okay, I said if the color is dark brown to even black, the soil has a high chance of being fertile. Okay, so moving on to conclude this whole lesson, there's an experiment that is performed, okay, on soils. Okay, I think the experiment will be in the next slide. So we pick a funnel, 3 different funnels. We put 3 different soil types: clay, loam, and then sandy. And then we put water into it. And then, so we use the experiment to measure the drainageability of the different soils. So you realize that at the end of the proportion time for the experiment, you realize that clay soil, the water that has drained from clay soil is very small. Then loam is in between, and then sand has a lot of water. So you find that the drawing of that experiment in the next slide. After that, the assignment would follow. So to conclude this whole lesson on soils, we have mentioned at least 5 soil properties. At least 5. Okay. 1, soil texture. 2, the water holding ability. 3, the structure. In other words, the arrangement. Okay, so soil structure. 4, the air content, also known as soil air. The the particle size. These are all physical properties of soil. The particle sizes, in fact, the organic matter content is even a physical property of soil. Okay, so off head, if you are asked to mention some soil properties, you should be able to mention at least five. Okay, there's the texture, the structure, the water holding ability, the particle size, the air content. You should be able to know all of them. Okay, all right. Now, sandy soils. We said that they are large. I remember I said it last week that the particles of sandy soil are large, and they are also irregular in shape. Okay, sandy soils, the particles are irregular in shape. So note it down. Okay, as for the space between sandy soil, we've already established that they have large spaces. So the large spaces allow air and water to pass through. Okay, clay soil particles are fine. Okay, they are fine, they are small and spherical. Okay, so we've said everything that there is to say about the soils. So we would end here. The experiment is on the next slide, followed by the assignment. Okay, thank you.